Aromaticity. Aromaticity in most of the aromatic compounds are derivatives of benzene. Okay, derivatives of benzene. Most compounds are derivatives of benzene. Most of the aromatic compounds. But there are certain compounds which are aromatic but do not contain any benzene ring. Okay, like non-benzenoid, they are called as non-benzenoid organic compounds. They are aromatic. Okay. Example is some heterocyclic compounds. Okay, in the ring contains the atoms other than carbon. Such compounds are also aromatic. Okay. According to the modern theory for aromaticity, it was advanced by Huckel. The modern theory was advanced by Huckel, and according to Huckel's theory, a cyclic compound must be aromatic. Okay, is aromatic if it possesses the following characteristics. Okay, if it possesses following characteristics. First one, the compound must be planar. Okay. Second point, delocalization of pi electrons in the ring. Okay, complete delocalization. Complete delocalization of pi electrons in the ring. Okay. And one more point is the third point. Third characteristics is they must contain. Okay, the aromatic compound must contain 4n plus 2 pi electrons in the ring. 4n plus 2 pi electrons in the ring, where n is an integer. Okay, n is an integer. Okay, and n is equal to 0, 1, 2, 3, etc. Okay. So if the n is equal to 0, there must be 2 pi electrons, like that it continues. Okay. So this rule is called as the HUCKEL'S rule. Okay. So according to HUCKEL'S rule, if a compound is aromatic, if it possesses the following characteristics, like first point, the compound must be planar. Second point, complete delocalization of pi electrons in the ring, and there must be 4n plus 2 pi electrons in the ring where n is an integer. Okay, n is equal to 0, 1, 2, 3, etc. Let us take some examples. First one, in the case of benzene, we know benzene is an aromatic compound. Okay, take benzene as an example. In the case of benzene, it contains 3 double bonds. Okay, it's a planar compound and delocalization of pi electrons is there, and third point is 4n plus 2 pi electrons. Okay, so we know n is equal to 1. There is only one ring. So 4 into 1 plus 2, that is equal to 6. 6 pi electrons must be there. Let us take, see, one bond denotes 2 pi electrons. Okay, so 1, 2, 3. That means there must be 6 pi electrons. So the compound is aromatic. So like that we can find another example. We can take another example. Furan. This is a non-benzenoid compound. It contains a lone pair electron and 2 double bonds. It is a planar compound. Delocalization is there. Okay, when 4n plus 2 pi electron system. Just see how many electrons, pi electrons are there. Here 2 bonds, so 4 pi electrons, then there is a lone pair, that is 6 pi electrons is there. So this is also aromatic. Okay, now let us take another example. In the case of cyclopentadienyl anion. Cyclopentadienyl anion. Here this carbon contains a minus charge. Okay. Here also we can see there are 6 pi electrons. Okay. So 4n plus 2 is following here, and it is also a planar compound. Okay. And delocalization is there. So this is also a aromatic compound. Let us take another example. in the case of azulene, azulene will be like this. Okay. This compound. Okay. So it is a planar compound. Okay. Delocalization of electrons is there. Okay. Alternate single and double bonds. Okay. What about 4n plus 2 pi electrons? 4n plus 2 pi electrons. Let us see. In this case, two rings are there. So 4 into 2 plus 2, that is equal to 10 pi electrons. It contains 5 double bonds. That means it contains 10 pi electrons. So it follows that. So this compound is also aromatic. Two benzene rings. Two benzene rings are fused. So this contains 2 rings. So delocalization is there. It's a planar compound and 4n plus 2 system. Let us see 4n plus 2 pi electron system. Here it contains 2 rings. 4 into 2 plus 2, that is equal to 10. 1, 2, 3, 4, 5. 5 bonds are there. So it contains 10 pi electrons. So this compound is also an aromatic compound. What about anthracene? It is a 3-membered fused benzene rings. See, here delocalization is there. It's a planar compound and 4n plus 2 system. 1, 2, 3. So 12 plus 2, 14 pi electrons are there. So we can see 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. So this is also aromatic. Okay. These are some of the examples. This much about the aromaticity. Okay.